m1 v1 plus m2 v2 equals to m1 plus m2 multiplied by 2. Okay? So that's for completely index collision. So that's the only tricky point for that problem. Any question here? So I will use this problem with for you to solve it. Now, I'm going to look at the next problem. It's about the two-dimensional collision. Okay. Two-dimensional collision. So for example, if you have two objects moving at different direction, and the light here after motion, it may move like this. Okay, so this is m1, m2, m1, m2. So you have v1, v2, u1, u2. Okay. But for two-dimensional collision, these velocities, v1, v2, u1, u2, they are not in the same direction. Okay. So to deal with this problem, you cannot just simply put the number, the magnitude of these velocities into your equation. So your equation, in principle, you still have the momentum conservation, but it has to be in the vector form. So it will be m1 v1 plus m2 v2 vector equal to m1 u1 vector plus m2 u2 vector. Okay. So this one equation corresponds to this vector equation. Okay. But we know that for the vector equation, you cannot deal with it directly. Okay, because all these coordinates v1, v2, u1, u2, they may be in different directions. So what's the general way to deal with vector equation? We always need to get the two components equation, right? So this one vector equation is equivalent to two components equation, right? One is m1 v1x plus m2 v2x equals to m1 u1x plus m2 u2x. Okay. And then you have m1 v1y plus m2 v2y equals to m1 u1y plus m2 u2y. Okay? So the equation you actually deal with will be these two equations, along x direction and y direction. Okay. Any question here? But of course, the important part is that then you have to know, for example, if I give you v1, v2, u1, u2, then you need to know how to decompose them to get v1x, v1y, v2x, v2y, u1x, u1y, like something like that, right? You have to know how to decompose them. And then you deal with component equation. And after that, for example, if we want to find, say, u2, but in the two equations, you are going to solve for like u2x and u2y, for example, okay? If you solve for u2x and u2y, how can you get u2? What's the equation for you to get u2 from u2x and u2y?
Square root of
the Pythagorean theorem, right? Square root of this and the square of this. Don't forget those general procedure. Again, it's just the application of vector addition. As we mentioned, vector addition plays the central role in all our manipulation here. Now, so that's the general stuff. Now let's look at our problem here. Okay, we have two balls moving along some different direction. And if the force collide and stick together, what is the velocity after collision? So the two balls stick together after collision. That corresponds to the spatial case, right? After collision, you have one object with total mass m1 plus m2 with velocity, the same velocity u. So the vector version of that equation will be m1 v1 vector plus m2 v2 vector equals to m1 plus m2, okay, u. And again, this vector equation, that means we have to deal with two component equation. One is m1 v1 x plus m2 v2x equals to m1 plus m2 ux, and then m1 v1y plus m2 v2y equals to m1 plus m2 uy. Okay. So for this problem, we're going to use the two equations, solve for ux and uy, and then we get. Any question here for what we are going to do? So now, okay, in this case, two boards approach each other. One is with mass of 10 kg, 3 meters per second velocity to the southeast direction. Okay, so something like this. Another one, 20 kg, 5 meters per second velocity to the north direction. Okay, after collision, they stick together, so they will be along some direction like this. Okay. We want to find the final velocity u. Okay? Now, in order to do the vector decomposition, so we have to plot the two velocity in Cartesian coordinates. So this is v1, this is v2. So v1x, this will be v1x, this will be v1y. Okay, this is the angle. What's the angle here? 45. Okay. So now, let's decompose v1, v2 to get v1x, v1y, v2x, v2y. Okay. v1x, okay? How to express v1x in terms of v1 and angle 45? Okay, so v1 cosine theta or cosine 45, so it will be, what's v1? 3 multiplied by cosine 45 square root of 2 over 2. So it's 3. Okay, you can get some number in meter per second. Okay, I don't have calculator, so I'm just going to use this number. V2 or V1y should be V1 multiplied by sine theta. Again, it's 3 multiplied by square root of 2 over 2. Okay, sine 45 is square root of 2 over 2. And is that correct? Okay, it should be negative. This one should be negative. It's along negative direction, V1y, right? So it will be negative. Okay, for V2x and V2y, you don't have to do the cosine sine stuff. You should be able to tell me directly. What is V2x? 0. What is V2y?
V2.
V2, so it's 5 meters per second. Okay? So these are the vector decomposition. Okay, do you still remember all these things? Now, then we can put them into the equation to calculate u1, ux and u1, right? So if we put into the first equation here, we get m1, which is 10 times v1x, which is this one, plus m2 multiplied by v2x, so 20 multiplied by 0, equals to m1 plus m2 equals to 30, right? So multiply equals to 30 multiplied by ux. So this will enable you to calculate ux equals to square root of 2 over 2, right? This is 0. Here you have 30 square root of 2 over 2. And divided by 30, so square root of 2 over 2. And this equation will enable you to calculate uy. So if you put all the number, 10 times negative this plus 20 times 5 equals to 30 uy. So this will give you uy equals to negative square root of 2 plus 10 over 3. Okay, here you can get some number in meter per second. You can get some number in meter per second. Okay. So that will give you ux and uy, the x and y components of the final velocity. So now, u has to be square root of ux squared plus uy squared. Okay, you can put this number and do the calculation. Please note that we want to calculate the final velocity. Velocity, by definition, is a vector. So you also need to calculate the, what should you also calculate? In addition to magnitude.
Direction.
Direction. So how can we express direction? The orientation angle theta equals to
Inverse tangent.
inverse tangent function of uy over ux. Okay, so that will finish this problem. Okay, any question here?